everyone, and welcome back to another one of our instructional build videos. Today's build video, guys, we're going to show you how to wire up your 55 Sphinx. So we have a wire management system that works perfectly for this machine. So I'm going to go ahead and go over a few of those highlights right now. So as you can see right here, we have an LED light ring, guys. This thing is awesome. It's going to illuminate your workspace here. It's very bright, perfect for any situation at any time of the day, guys. And over here towards the back of the machine, you'll see that we've got our X-axis drag chain established here, which is also part of our kit for perfect wire management. And we've also utilized our OpenBuilds modular system for our 20x20 cable tray. In addition to that, we've also got our micro limit switches that are going to be included in this kit, so we can always run a homing sequence for ease of manufacturing, guys, which is awesome. And right here on the back of the machine, guys, we have our OpenBuilds open case, which is perfect for the mounting of our Xpro controller, which we're utilizing on this case for this build video, but you can also use multiple different controllers on this configuration. Very nice addition to this kit, guys. So now that we have all the highlight points addressed here for our kit, guys, we're going to go ahead and give you the overview of what we're going to be addressing here in our build video. So we're going to go over all of the wire management here, how to assemble our drag chains, how to install our LED light ring, our micro limit switches. We're also going to be configuring our settings in the OpenBuilds controller. So we're going to get your machine up and running. All your values are going to be inputted into your controller, and you guys are going to be running a hello world by the end of this video. So let's go ahead and get started. Alright, guys, so on this first step we are going to be assembling our female connectors to our 4-conductor wire. So we have 4 sets of wire here, 3 being at 2.5 feet, and we have 1 at 7 foot. And all of these are going to be assembled here with our female connectors. Now, one thing I want to show you before we go ahead and start is our male connectors have been connected to our motor. So if need be, this kit does come with the male connectors. Just snip off the excess wire and connect your male pins. Make sure you do it in this order. These are the coil pairs: red, green, blue, and yellow. So make sure that those match. So I've done that for every single one of my NEMA 23 motors for our 55 Sphinx. So that's 500 by 500 millimeters. So if you have the new style of motors, which comes with a male connector already assembled onto the motor, your coil pairs are going to differ. So you're going to have red, blue, green, and yellow as your coil pairs. So as you can see, the motors with the leads, which we'll be doing in this video, those coil pairs are red, green, blue, and yellow. So for the new style of motors, we have red, blue, green, and yellow. So that's the difference. If you need to pause the video, go ahead and do so. That way you can see the difference in colors. But basically all you have to do, since these coils are already paired off for your convenience, you take your female connector and you're going to correspond your 4-conductor wire to each one of these colors on your motor. So you're going to have red, blue, green, and yellow. So you're going to be working right to left. And then this will relay to our controller. And from there I'll show you another set of wires attached to the controller. That way there's no confusion. So let's go ahead and continue. So basically with the lead extensions, we're going to be wiring these in particular throughout this video. So if you do have these motors, just follow along. If you have the new style motors, please pay attention to the colored wires and make sure that you wire it corresponding to your motor. Alright, so let's go ahead and continue. Alright, guys, so once you have that complete, we're going to go ahead and start here with our female connectors. We're going to line these up with our male connectors. So in order to get a true bond between these wires, we need to make sure that each one corresponds with the other. So in this case, we'll be running red on the right side of this connector, green next to red, blue next to green, and then yellow next to blue. Alright, so let's go ahead and get started here, guys. So one thing I will say about these connectors is you need to make sure that they are completely loose on the pins. So I'll go ahead and give you an example here. You can see that my pins are at the top portion of the plastic. As I loosen these, you'll see that the metal pin actually comes down. So we want to make sure we do that with all of our connectors so we can get a true connection between our wire and our connector. Alright, perfect. So let's go ahead and get started. So remember, we're going right to left with the pens facing up. So red's going to go here, and then we're going to work our way down. Push them in so the insulation is completely into the slot, and then tighten it down. Alright, and then next is going to be blue. And then following blue is our yellow. Alright, give those a nice tug, make sure they're not coming loose. That looks great. So that's one of our 2.5 foot wires. So we're going to go ahead and connect that to our Y-axis motor here on the right side of the machine. So that's facing the back of the machine here. So let's just go ahead and plug that in. As you can see, all of our wires do correspond. Excellent. Alright, so we'll just leave that back here. Alright, and let's move on to our next wire. So same thing, guys. Let's go ahead and get all these wires fixed onto our female connectors. Alright, that looks great. Make sure to give it a little tug. Those wires are in there. Alright, so on the left side here, we're going to connect it just like so. Perfect. So we'll just leave that down here. Now let's move on to our next wire. Alright, so this is our additional 2.5 foot wire. This is going to connect to our X motor. Let's go ahead and connect that. Perfect, and we'll leave that to the side for now. So now moving on to our 7 foot wire here. This is going to connect to our Z-axis. So right there. Alright, so let's go ahead and get that done, guys. Alright, perfect. So this will be our last connection that we're going to make. So make sure that everything lines up, guys. Alright, perfect. So now we're just going to leave this one off to the side. And let's go ahead and move on to the next step, guys. Alright guys, so on this next step we are going to be assembling our micro limit switches. So as you can see here, I have 2 already assembled, and then I have 1 broken out here for you. So inside your micro limit switch, you should see a micro limit switch plate, a micro limit switch, one of our M5 8mm screws, a drop-in T-nut, slot washer, 2 of our M3 self-tappers, and 2 of our spade connectors. In addition to that, we're going to have our wire for this step. We have 2 of our 2 conductor wires at 7 feet and 1 at 2.5 feet. And as you can see, these are examples here of how the spade connectors connect to your wire. So one end is going to have your spade connectors, which are going to then attach to the micro limit switch. And then you're going to have your pigtail here, which is going to attach to your Xpro. So we're just going to leave those there for now. And let's go ahead and assemble this micro limit switch. So here, taking the plate, we're going to place this micro limit switch in a horizontal configuration. And what I mean by that is it's going to be placed horizontally on our micro limit switch plate. So essentially, we're going to align it with each one of the holes here on the plate. We're going to take one of our self-tappers, and this is actually going to tap the threads into your micro limit switch as you're screwing it in. So let's go ahead and tighten that. And try to keep your micro limit switch as straight as possible, guys. Alright, and then our next. Perfect. So now the micro limit switch is mounted. So from there we're going to take our 8mm screw and run it through the front face here. Take your slot washer, make sure the flat end is facing away from the plate. And let's go ahead and thread on our drop-in T-nut. that's another micro limit switch that is assembled. So we're going to set that with the rest of them. Our spade connectors, we're going to go ahead and connect to both ends of our 2-conductor wire. So here I'm just going to slide this into the spade connector, and you can see that my wire is protruding through. That's what you want. Then from there we're going to take our wire strippers and crimp this from the top. And you really want to make sure to put some force on it, make sure that that wire is not coming loose. Alright, that's perfect. So now we're going to do that again for our black wire. Alright, perfect. So it's simple as that. So now we're going to go ahead and configure our micro limit switches with our wires here. So on our micro limit switch, you're going to see a C for common, NO for normally open, and NC for normally closed. On this configuration, we're going to use the common and normally open. Now the common is going to be our negative, our ground, and then our positive is going to attach to our normally open. And the normally open is going to be our positive, the red wire. So just connect those to the terminals. That looks great. So we'll put this one to the side. And let's move on to our next micro limit switch. Same exact thing. Black to the common, red to the normally open. Alright, excellent. So all of our micro limit switches are configured properly. So now we're going to go ahead and mount these. So for our Z-axis, which is going to be one of our 7-foot wires, we're going to place that right here in the channel of our C-beam on the Z-axis. So go ahead and locate your 7-foot cable. You should have 2 of them. Alright, and from there, we're going to go ahead and place this right into the C-beam channel. Excellent. So this pin is going to activate the homing sequence. So let's go ahead and test to make sure that our gantry plate does activate that switch when it comes up. Yep, that works great. So that's perfect, guys. So that's one micro limit switch down. Just going to toss this wire over to the back end. Alright, so next is going to be our x-axis. So I'm just going to move this gantry down slightly. And our x-axis is also going to be using a 7-foot wire, so go ahead and locate that one. And here on our C-beam, we're going to go to the front channel here for our micro limit switch, and we're going to mount it in line with our y-axis C-beam. Alright, and to test that, we're going to go ahead and bring our gantry over, and the wheel should activate the micro limit switch. Perfect. So as you can see, it's activated the switch, and then it releases. So you can adjust this if you want. If you want to move it back further, it's completely up to you. Alright guys, so moving on to the y-axis micro limit switch here. We're going to go ahead and mount that to our front channel here of the y-axis C-beam. This is on the right side of the machine here, where our motor is attached for our x-axis. So what we're going to do is place it in the top track here, and then we're going to mount that into place. Alright, perfect. So now when our gantry plate comes forward, it will activate our micro limit switch. Alright, so now we have our micro limit switches assembled, and they're placed in the configuration necessary. This is looking really sharp, guys. Alright, let's go ahead and move on to the next step. Alright guys, so moving on to the next step here, we're going to go ahead and assemble our LED light ring to our router spindle mount here on our Z-axis. So in this step we're going to require our LED light ring and the contents included, which are the M5 6mm screws. In addition to that, we're going to have 7-foot 2-conductor wire, and then our tooling is going to be our M5 ball driver and our flathead screwdriver. Alright, so let's go ahead and get started here, first by taking off our router spindle mount. So here on our black angle corner connectors, we're just going to loosen these screws that are attached to our double wide gantry plate. Alright, once that's complete, I just usually take the screws out. So we're going to flip our router spindle mount upside down, and we're going to take our LED light ring and we're going to place it right on top. And you're going to see two holes here in the middle, and this is where we're going to go ahead and mount our LED light ring. So take two of your 6mm screws and place them in these holes, and then we're going to tighten them down. Alright, perfect. So now that our LED light ring is mounted, we're going to take it and mount it back to our double wide gantry plate. So the two threaded holes that you first see from the bottom of the plate, that's where your black angle corner connectors are going to mount. So just go ahead and take your M5 8mm screws, and let's go ahead and screw this back into place. Alright, perfect. So now our LED light ring is mounted to our router spindle. So here on the right side you're going to see our connector. So we're going to loosen these pins. And on the right side it's going to be positive, on the left side is going to be negative. So we have indications here on the bottom of the LED light ring as well. So if you want to reference back to that. So our positive being the red wire here, we're going to go ahead and insert that on the right side. Alright, give that a little tug, make sure those wires are in there, and that looks great. Alright, so we're just going to toss this wire over with the rest, and let's go ahead and move on to the next step, guys. Alright guys, moving on to the next step here, we're going to go ahead and label all of our wires. So we want to make sure that we know exactly what's going to go where. So let's go ahead and grab some painter's tape and a black Sharpie, and let's go ahead and get started here, guys. So finding the point of origin for each wire is essential here, guys. We want to make sure we're labeling these correctly. So here I have my X-axis motor. So I'm going to find the wire that corresponds. And obviously motors are going to have 4 conductor, micro limit switches and the LED light ring are going to have 2 conductor. So let's go ahead and grab some painter's tape here. I just grabbed like a little sliver. And I'm going to wrap this around the wire completely. And the reason for doing this is if you create a flag, which it is easier to write on, it's going to snag on your cable chain, it's going to rip it off, and then you're not going to have a label on your wire. So make sure that you go fully around the wire here. And I'm going to indicate this just by X. So that's going to indicate that this is a motor. And with my micro limit switches I'm going to add an M. So this is just strictly X. Perfect. Alright, so let's move on. Here I have my Y-axis micro limit switch. And I'm going to indicate this by YM. Just like so. Perfect. Alright, next we're going to go to our Y-axis motor here. And this one is going to be labeled Y. Alright, and here on the right side of the machine, if you're facing the back, this is going to be our A-axis motor. And this is a slave axis to the Y. So we just want to make sure we label that A. Since this is a Cartesian style machine, both axes are running in unison, so we want to make sure that we have those plugged in the right ports on our Xpro. So now we're moving on to the Z-axis here. So this is our Z-axis motor. Alright, and then we have our Z-axis micro limit switch. It's going to run from the top here. So I labeled that ZM for Z micro. And then we're going to move on to our LED light ring. And we're just going to label this one LED. Now we're moving on to our X-axis micro limit switch. And we're going to label that XM. Alright, perfect. So that's all of our wires completed. They're labeled. So that's perfect for wire management here, guys. Alright, so let's go ahead and move on to the next step. Alright guys, moving on to the next step here. On this step we're going to be assembling our X-axis drag chain, and we're also going to be assembling our cable chain tray. So we're going to use a 20x20 for that. We also have our additional slot cover at 500 millimeters. We're going to have 3 of our single L brackets, 3 of our M5 15 millimeter screws, 2 of our M5 8 millimeter screws, 2 of our M3 8 millimeter screws, 3 of our M5 T-nuts, 2 of our M3 T-nuts, 2 of our drop-in T-nuts, 2 of our 6 millimeter aluminum spacers, and 2 of our slot washers. And of course, our tooling is going to be our M5 ball driver, M3 ball driver, and we've got some of our wire strippers. So let's go ahead and get started here, guys. First off, I want to go ahead and display how our slot cover is going to go into the 20x20. With the V-slot, it tends to be difficult to snap it into place, so we're going to go ahead and slide our slot cover in the end of the 20x20. And what we want to do is leave some excess here. We're going to cut off any additional excess because we want a release here for our wires. So if this was to completely cover the wires, we wouldn't be able to run it through our Y-axis drag chain. So we're going to go ahead and pull this back slightly, say about 1.5 inches away from the end of the 20x20 here, and we're going to snip off the excess. Alright, and we can hang on to the excess, we'll use that later. And as you can see, on both ends I have space so I can run my wires through. So that's perfect. Alright, so from there we're going to go ahead and grab one of our single L brackets. Making sure our spacing is configured properly here on the single L bracket, we want to make sure the spacing that's closest to the seam is going to attach to our C-beam here on the X-axis. So that being said, let's go ahead and run a 15 millimeter screw through this hole, add a 6 millimeter aluminum spacer, one of our slot washers, and a drop-in T-nut. We're just going to go ahead and thread that on. Alright, from there we're going to go ahead and attach this to this bottom channel here of the C-beam. Alright, perfect. Alright, so we're going to do that again for the left side. Alright, perfect. So now that that's complete, I want to go ahead and show you how we're going to go ahead and mount this 20x20. So the 20x20 is going to mount from underneath the single L bracket, just like so. So we need to run T-nuts in each side. So first we're going to run an M3 T-nut here on the left side, and that's going to attach to our drag chain. And we're going to run an M5 T-nut after, making sure of course your lip here is facing the inside of the track. Alright, then here on the right side we're going to run one more of our M5 T-nuts here, and that's going to attach to our single L bracket. Alright, so we're going to go ahead and align this to each one of our single L brackets. Take one of your 8 millimeter screws, and we'll work on one side at a time. Just tighten that down. Perfect. Alright, so let's work our way to the right side. And what I like to do is make sure I even out the sides here. You can see I have some excess hanging. So we're going to go ahead and move this single L bracket down slightly. Just like so. And then tighten that back down into place. Alright, perfect. So that is our cable tray, guys. That looks really good. Alright, so from there we're going to focus on our drag chain. So the first thing I want to show you guys is how this configuration is going to be set up. On one end you're going to see an end cap of your drag chain, which all these links are modular, so you can grow this to any length or shorten it. Or you can also rotate these end caps based on how you want to mount the drag chain. So that being said, this is configured for this assembly in itself. So this is how the drag chain is going to mount to our 20x20, and then from the X carriage plate, this is how it's going to mount to our L bracket. So it's actually going to mount from underneath the L bracket here, and it's going to be tightened by an M3 T-nut. So make sure your end caps match what I have here. So one being at this end, the other being flipped. Alright. So now we're going to take our additional L bracket here, same configuration with the spacing closest to the seam, and we're going to mount this to the center hole here in our X carriage. So taking one of our M5 T-nuts, we're going to thread that onto the screw. And what's really cool about this is just really a display of the modular system of OpenBuilds. So you can modify and create new things and new designs based on these parts. And you can also create simple solutions. We're adding a cable tray here with L brackets and a 20x20. We're using a slot cover here with our T-nuts to mount the drag chain, also to hold the wire in place with the slot cover. And this stuff's awesome, guys. It really looks sharp. Alright guys, so first thing we're going to do is we're going to go ahead and run our X-axis micro limit switch through our slot cover and out the other side here, and that's going to come through the bottom portion of our drag chain. So what I like to do is feed this through the slot cover. And what you can do is pop the slot cover out of the slot, so we can pull that slack out, and then simply place the slot cover back into the 20x20, just like so. Alright, so remember this is going to run through our drag chain as well, so we'll just leave that as it is. Alright, so now I want to pay attention to these three wires. These are all going to be running through our X-axis drag chain. So we're going to take each one of these wires, let's go ahead and find the ends, and we're going to run it through our X-axis drag chain. Alright, make sure that you're running these wires through the front end that's going to be attached to our X carriage. So this end here is going to be the front, and let's go ahead and feed those through, guys. Alright, so once we have those ran through the drag chain, we want to make sure that we have some slack here at the top portion. That way we can configure the drag chain to the single L bracket. Alright, that's perfect. Alright guys, so here on the opposite end we're going to run our X-axis micro limit switch through the bottom of the drag chain here. And then here on the center hole of our drag chain, we're going to mount that to our M3 T-nut that's underneath. So let's grab one of our M3 8mm screws, and we'll run it through that hole. And let's go ahead and tighten that down, guys. Alright, that's perfect. And now for the top portion of our drag chain, we're also going to use the center hole, and we're going to run it from underneath. So just push that through, and let's go ahead and attach our M3 T-nut. Alright, perfect. That looks excellent, guys. Alright, so now we have our X-axis drag chain assembled. So now we're going to go ahead and move on to the next step, guys. Alright guys, so moving on to the next step here, we're going to be assembling our Y-axis drag chain. And in order to do this, we're going to configure our single L brackets to both our 20x20 as well as our 20 by 60 here at the bottom. So the first thing we're going to do is identify all our parts here. We have 2 of our single L brackets, 1 of our self-tapping screws, 2 of our M3 8mm screws, 2 of our M3 T-nuts, of course our Y-axis drag chain. We're also going to need our 500mm slot cover, which is going to cover our micro limit switch wire here on our top slot of the C-beam. So to start this off, guys, we're going to go ahead and take our power drill and we're going to pull off this end cap here on the end of our 20 by 60. So just simply take your drill and let's pull that end cap out. Alright, now this self-tapping screw we are going to reuse. So taking our single L bracket here, making sure that the spacing that's closest to the seam is going to attach to our 20 by 60. So let's take our self-tapping screw here and we're going to mount that single L bracket into place. Perfect. Alright. So now we're going to go ahead and move on to the 20 by 20 here. So right on the end of the 20 by 20 we're going to mount our other single L bracket using our self-tapping screw. So once again, using the spacing that's closest to the seam here, we're going to mount this to our 20 by 20. And the way that we're going to mount it is just like we did the other one, with this bracket hanging down. So let's go ahead and mount that into place, guys. So now moving forward, we're going to configure our Y-axis drag chain. So the way that this is going to mount is our end cap on the top portion is going to mount underneath of our single L bracket, just like so. And then our bottom portion here is going to attach to our single L bracket on top. Now for both of these we're going to be using the left hole here. So first we're going to go ahead and run our wires through the drag chain, but make sure that you have your drag chain configured properly. This end cap should be facing like so, and then the bottom should be flat. Alright, so let's go ahead and we're going to take all of our wires, including our X-axis motor, and we're going to run this through our Y-axis drag chain. So once you have all of your wire ran through, we're just going to pull the additional slack from the wires that have the excess. Alright, perfect. So you should leave a little slack here on the top portion. That way we can configure our drag chain. So from here, we're going to go ahead and mount our drag chain from underneath to our single L bracket. So just run one of your 8mm screws through. And we're going to go ahead and put on one of our M3 T-nuts. So then go ahead and tighten that T-nut down. Perfect. Alright, that's looking really sharp, guys. So we're going to go ahead and mount our additional portion of our drag chain here to our other single L bracket. Remember, we're using this left hole here, guys. So for this section, I'm going to pull my machine back slightly. That way I can access it and tighten it from the bottom. Alright, perfect. So now that those wires are ran through our drag chain, this is looking really sharp, guys. We're going to just run these towards the back, and those are going to connect to our Xpro. Now we have our Y-axis micro limit switch. So for this, we're going to go ahead and run our slot cover through the front track here. And the same with the X-axis we're going to do with the Y. We're going to trim off just any additional excess here. That way we can run our wire completely through the slot cover. So as you can see, I have space here as well as here, so my wire can run through without any interference. So from there, we're going to feed our wire through the slot cover. And once it comes through the other side, we're just going to pull that slack. And we're going to run that back with the rest of our wires here. Alright, perfect. What I like to do is push the wire up and over. That way I can tuck it into the plate like so. That looks great, guys. Alright, so now we have our Y-axis drag chain configured. And this looks really good, guys. It's really starting to come together. Alright, so let's go ahead and move on to the next step. Alright guys, moving on to the next step here. On this step we're going to be attaching our wires to our Xpro controller. So what we need to do is locate the sections that we're going to insert our wires into. So we have our Y-axis motor, X-axis motor, and each one of these also has their limit switch sections. And then on the opposite end here, we also have our A-axis motor, which is going to be for our slave axis, our Z-axis motor, and of course our limit switch. So the Xpro controller I want to assemble before we put the case on, and the reason for that is once the case is placed underneath the Xpro, it's hard to get into these pins. So we're going to go ahead and insert our wires before we assemble the case. So what we're going to do now is go ahead and loosen every one of these pins. That way we can prep for inserting of our wires for our motors and micro limit switches. Alright, perfect. So every one of our pins is loosened. So we're ready to go ahead and grab our first wire here. So what I have is our Y micro limit switch. So here on the bottom section you'll see an indication for Y, and next to that's going to be the limit switch. We have our ground here to the right, and then our positive section here on the left hand side. So we're going to insert red on the left side, black on the right side. So what I like to do is twist the wires first to make sure I get a good connection. And let's go ahead and insert those wires. Alright, and once you have those inserted, just go ahead and tighten those pins down. Then give those wires a tug, make sure they're not coming loose. Alright, that looks good. So next to go in here would be our Y motor. So let's go ahead and locate that. So right here we have labeled Y. And of course it's going to be a 4-conductor wire. And for this one we're going to go red, green, blue, and yellow. And that's our coil pairs running off of our motor. So as you can see here, all of our wires are corresponding. So we need to go in that order with our Xpro. So right here we have section A1, A2, B2, B1. So red, green, blue, and yellow, guys. Alright, so if you have the new style of motors with the male connectors attached to the motor, this is how you're going to wire up your controller. So this is all based on the coil pairs. So we have red, blue, green, and yellow. And that's going to follow on every single axis. So as you can see, there's no difference in the ordered pair on either one of my axes. So that's for a lead screw driven machine. Now with a belt drive that will differ, and throughout that video I do show you the same exact picture here of the controller setup. So if you do have the new style of motors, make sure that you follow this, pause the video if you need to, but these are the coil pairs and how they're going to align to your controller board. And you need to make sure that every single one corresponds. So if you were to look at the new style of motors, and if you were wiring your motor directly into your Xpro controller, you can see we have it aligned. So this is just based on the motor coil pairs aligning to your controller. The only thing that we're doing is we're adding that extension length, which is going to connect to our male connector here from the female. And all of those connections are going to relay to your controller, and it comes back to the simple concept of the motor coil pairs just aligning to the controller properly. That way when you configure this into the software, you have no problems. So just make sure you pay attention to this, and if you do have the lead extensions, which are what we hooked up to our motors here, those lead extensions coil pairs are going to be red, green, blue, and yellow, and those will be configured in this video. So I'll be showing you how to insert each wire into the pin and clamp it down. And the micro limit switches, of course, for this controller, this is all going to be the same. The only difference is the ordered pairs of your motor coils. So make sure that you pay attention to this, guys. I'll also add a link in the description for this diagram, both motor and controller. That way you guys do have a diagram that you can look at. But this is pretty simple, you just need to make sure to get it correct. Alright, so let's go ahead and continue. Alright, so once red and green are inserted, we're going to go to blue and yellow. Alright, and give those a tug. Make sure they're all inserted and clamped into the Xpro properly. That looks good, guys. Alright, so we're going to go ahead and move on to our next section here. So this is going to be for our X-axis. So let's locate our X motor. Alright, so here for the X-axis, we're going to insert our wires the same exact way, guys. So it's going to be red, green, blue, and yellow. And of course our micro limit switch is going to be red and black. Alright, so let's go ahead and get that done. Alright, so give those a tug. Make sure that they are tight. That looks great. Alright, one other thing that I will mention, guys, is the insulation here needs to be fully inserted into the pin. You don't want any of the wire exposed, because if it were to touch the other port or the board itself, you could burn out a driver. So be very careful, make sure you do this correctly, guys. Alright, so let's go ahead and move forward. So we have X, Y. So now we're going to go ahead and move on to the X micro limit switch. So let's go ahead and locate that. So here's our X micro limit switch. So let's go ahead and insert that next, guys. Remember, we're going to go red and then black. So we have our ground here and our positive on the right side. Alright, give those a tug, make sure that they're fully inserted. That looks great. Alright. So now we're going to move on to our slave axis, which is our A-axis motor. Now this one we're going to actually configure to be inverted through our software. So we're going to align those wires the same way we did the other axis. So red, green, blue, and yellow is how we're going to line this up. So red, green, blue, and yellow, guys. Alright, now that we have our A-axis in place, just give that a little tug, make sure those wires are inserted properly. That looks great. So now we're going to move on to our Z-axis. It's the same thing, guys. Red, green, blue, and yellow, and then red and black for our micro limit switch. So let's go ahead and get that done. Alright, perfect. So just give those a tug, make sure that they're fully inserted. That looks great, guys. So now we have all of our wires configured into our Xpro properly. So let's go ahead and move on to the next step. Alright guys, so on this step we're going to be assembling our Xpro plate. So we're going to require 2 of our plates here, 1 of our brushless fans. In addition to that, we're going to need 8 of our M3 T-nuts, 2 of our slot washers, 2 of our 3mm aluminum spacers, 2 of our drop-in T-nuts, 4 of our precision shims, 4 of our M3 12mm screws, and 12 of our M3 20mm screws, 4 of our M3 hex standoffs. Alright, let's go ahead and get started here, guys. First, by taking one of our plates, I'm going to place it underneath the Xpro. And from there you're going to see some holes line up with the Xpro. We're going to feed 12mm screws through those. So go ahead and grab your M312s and we're going to run those through. Alright, from there we're going to put our M3 T-nuts on the back end of the plate. So I'm just going to stand this up to where I can access the screws. And let's go ahead and thread these onto the plate, guys. Alright, perfect. So now we're going to just go ahead and snug these down. We don't want to over tighten it because it will flex the board. So just be careful. Make sure it's tight but not too tight. Alright, perfect. So now we have our Xpro mounted. That looks excellent, guys. So what we're going to do now is go ahead and mount our fan to our back plate. So in the same style that we set our Xpro, we're going to do our fan. So what I mean by that is the back of the plate, you'll see that the OpenBuilds symbol is upright. We're just going to match that just so we have consistency amongst the plates. You don't want to mount it backwards, it'll look weird. Alright, so with our fan, we're going to run our 20mm screws from the back end of the plate because the fan's going to be on the inside. So we're going to have 4 holes here on the outside that's going to mount to our fan. So let's see by placing the fan which holes that they line up with. So if you need to do that just to find the holes, go ahead and do that. So let's go ahead and run our 20mm screws through. Alright, so I'm going to rest the plate on its back here. So the first thing we're going to do is add these precision shims for spacing. Let's go ahead and bring our fan in, making sure that the sticker is facing you. And that's which direction the fan is going to be blowing. So we want that air to circulate onto our Xpro board. So now grab your M3 T-nuts and let's thread these onto our screws. That looks excellent, guys. Alright, so now from here, I'm going to set this to the side. Our additional 20mm screws, we're going to run through each edge of the plate. So all of these holes here on the edge of the plate, we're going to run those screws through. And we're going to add one of our M3 hex spacers. We're just going to thread that on. just like so. So let's do that for our additional 3 holes. Alright, perfect. So now all of our hex standoffs are in place. So what I want to do now is go ahead and insert our 15mm screws. So on each end of the plate here, you're going to see duplicate holes here, so you can mount from the top or from the bottom. In this particular case, we're going to mount from the bottom. So we're going to run our 15mm screws through these 2 holes. And from there we're going to add our slot washer. We're going to add our 3mm aluminum spacer, and our slot washer, and our drop-in T-nut I'm just going to thread into place. This is just going to make it easier to mount this plate. Alright, we're going to do the same thing for our bottom screw here. So let's get that done, guys. Alright, perfect. That's looking really sharp, guys. So we've got our fan mounted onto the case as well as our Xpro. This is really looking pro. Alright, so what we're going to do is our additional screws here are going to be for closing this case. So they're going to mount into the top portion of the plate, and then it's going to stick into our hex standoffs. So we're going to actually carry these over into our next step, because I want to show you guys how to insert your power wire that's going to be powered by your power supply. Alright guys, so let's go ahead and move on to the next step. Alright guys, so moving forward here, on this step we're going to go ahead and hook up our power supply. We're going to need our power wire that's going to plug into the outlet and power our power supply. We're also going to need our power wire, which is going to connect from the power supply to our Xpro, providing power for the Xpro controller. In addition to that, we've carried over our 4 M3 20mm screws. We've got 15 zip ties here that should be included with your kit. In addition to that, we're going to have our tooling, our Phillips M5 ball driver, and a flathead. Alright, so let's go ahead and get started here. We're going to grab our power cable. You see I have these pre-stripped, so if you don't have these stripped down, guys, just go ahead and do that. Alright, and here on the power supply we're going to have indicators here for ground, neutral, and line. So the way that that's going to correspond with these colors, green is going to be ground, black is going to be our line, and white is our neutral. So let's just loosen up these terminals here. Alright, and let's go ahead and insert those wires in this order. Alright, perfect. Give that a little tug, make sure that those wires are inserted properly. Make sure that the insulation is fully into the terminal as well, guys. You don't want these coming loose and causing an arc. Alright, so now that we have that completed, let's go ahead and take our power wire. We're going to go ahead and connect that to both positive and negative here. So you see we're split at 3 and 3. I'm going to insert my red wire here for the positive, right here, and then the black wire here for my negative. So let's go ahead and get that done. Alright, perfect. So from the opposite end of the wire here, we're going to go ahead and connect that to our Xpro. So what I like to do is just make sure that these wires are twisted and all together as one unit. Then we're going to loosen up these pins here in the power section of our Xpro. You want to make sure that those are fully inserted, guys, all the way to the insulation. And let's tighten it down. Give those a tug, and that looks great, guys. Alright guys, so next we're going to go ahead and zip tie our power wire here. So basically you'll see 2 holes here, and that's where we're going to zip tie this power wire. And the main purpose for doing so is we don't want this power wire coming loose. So if there was any type of pulling motion on this power wire, the zip tie is going to take the majority of the force. So you're not having to worry about these wires coming out and causing a short in your board. Alright, so we're going to go ahead and run the zip tie through. And let's go ahead and tighten that down, guys. And we'll just take some snips. Let's go ahead and snip off the excess here. Perfect. Alright, so you see that's nice and tight. It's not going anywhere. It's exactly what we want, guys. Alright, so next we're going to bundle these wires. What I like to do is keep them consistent and together. You see that we have excess. So it's completely up to you on how you want to configure this. If you want to snip off the excess and have a direct line into the controller, that's up to you. You have that excess for that purpose. What I like to do is bundle these wires together just in case I wanted to configure this differently. I could move it down on the rails. So basically I would keep that excess in the bundle for that purpose. So what I like to do is I'll take the wires that have the extra length and I'm just going to bundle these together. Now the only one I'm going to leave out is my LED wire. That's going to connect to our power supply. And then of course our A-axis slave motor here is going to run out the opposite end of our controller because it's on the right side. But other than that, I'm going to keep these in a bunch like so. And then I'm just going to zip tie them together. Go ahead and snip off the excess here. And then from there, I'm going to bring it in to the controller, making sure I don't block the circuitry here. I want to make sure that it's cooled by the fan. So generally I'll put it down here at the lower half of the case. It's just like so. So from there we're going to go ahead and plug in our fan. So we have indicators here on this section, which is for the fan. You're going to see positive and then a negative. So this is exactly how it's going to connect, just like so. Then we're going to place the case on top, and we're going to screw it into place, guys. That looks excellent, guys. So now what we're going to do is go ahead and latch this to our 20 by 60 rail here at the bottom. So taking our M5 ball driver, we're going to go ahead and latch those T-nuts into place. Alright, perfect. So now our Xpro is configured properly. It's on the left side portion of our machine. That looks excellent, guys. Alright guys, so next we're just going to go ahead and attach our LED light ring to our power supply. So here on our output section, we're going to have positive and negative. We're simply going to plug the positive into the positive and the negative into the negative on the outputs. So I'm going to place my positive here, clamping that down. And then my negative, I'm going to go right here in this terminal. And then tighten that down, guys. Alright, perfect. So now that that's configured properly, we're going to go ahead and work on some of the aesthetics here with our zip ties. Starting here at the back end, I want to go ahead and clamp this connector down. Keep that tight just in case there was an issue with the machine moving or being pulled, wires being pulled. You don't have to worry about your connectors coming loose. Alright. And of course, it's completely up to you how you want to configure this. This is just a way that works for us. So basically what I'm doing is just making sure everything's nice and uniform, guys. Alright, now we're going to work our way over here to the slave axis motor. And we're going to do the same thing, just make sure this connector is not going to come loose, guys. Alright, now I'm going to rotate the machine 90 degrees. And we're going to clamp this connector down as well. Alright, and then these additional wires, we're going to go ahead and tighten those down as well. Alright, now move into our Z-axis here. Alright, now we're moving on to our micro limit switch here on the Z-axis as well as our LED light ring. What we're going to do is take our two pieces that we cut off of our slot cover and we're going to utilize those for these slots. So bringing both wires up to a position to where we can set the slot cover. We're going to pop that into place. Alright, and then our additional will lock into that micro limit switch wire. Alright, perfect. Then I'm going to zip tie these together. Alright, that's looking really good, guys. So let's go ahead and move on to the next step. Alright guys, so what we're going to do now is go ahead and plug in our USB cable so we can communicate to our laptop. So we're going to insert that to this top portion here of the Xpro. And then plug the USB cable here into our laptop. Alright guys, so the first thing we're going to do is open up our browser. And we're going to go into OpenBuilds.com. Alright, from there you're going to see tabs here for software. We're going to select that. And we're going to download the OpenBuilds control machine driver. Alright, we're using Windows, so we're just going to go ahead and download. Alright, once it's finished, we're going to open it up. And here you're going to get a Windows Protected Your PC prompt. We're just going to go to More Info, and we're going to run anyway. Run through the prompts, and we're going to install. Alright, finish. Alright, OpenBuilds has started the driver, so we're going to select it. And here you're going to see our OpenBuilds machine driver. Okay, since we have our Xpro connected and it's not powered on by the power supply, we're just going to go ahead and connect the COM port. We're at COM 10 here, so we're going to select that and connect. Alright, so now we're connected in. We need to adjust our settings. So every single one of our values here need to be set up for a lead screw driven machine. Our parameters also need to be correct for 500 millimeters by 500 millimeters. So let's go here to settings, and then Gerbil settings is going to populate at the top. Select that, and here we're going to see our parameters and our values. So these are preset, but we're going to go ahead and adjust these according to our machine. So let's go ahead and go back to OpenBuilds. And here we are going to go into the OpenBuilds machines so we can find the settings. So on each one of our build pages, we're going to populate settings for you. So all the values are calculated specific to that machine. So it's really convenient. All we have to do is locate it here on the build page. So we're looking for the 55 Sphinx. Let's go ahead and select that. And scrolling down, you're going to see descriptions of the machine, nice rendered files here of the machine's footprint, more specifics. It's really cool stuff, guys. If you ever get the chance, check it out. So of course we're going down to our settings here. You're going to see Sphinx 55 Gerbil settings. So here it says set your board to 1/8 steps, which they come stock. And here it's going to go ahead and give you the values that we need. So let's go ahead and select, click to expand. All right. So here for 0, it's going to equal 10, so that's correct. Our second is going to be 255. That's correct. 2 is going to be 0, so there's no inversion here. That's correct. Going down to 3, that's going to be set at 4. So here it's going to show you we're going to invert X and Y. So let's select 4. 4 here is going to be invert step enable pen. And here on the section it's going to show 1, so that's going to be enabled. That's correct. 5 is disabled. It's 0. 6, as you can see over here, this is 0 as well, so that's going to be disabled. Going to 10, this is going to be set at 1, so we'll change that. Here at 12, we have 0.002, that's correct. 13 is also disabled, so that's correct. 20 is 0, so that's disabled. 21 is 0, that's disabled. Now our homing cycle, we are going to enable, so just select enable, and that's because we have our micro limit switches connected. If you did not, you would just leave that disabled. Alright, so going on down to 24 here, we see that this is the homing feed. So we're going to select, this is a locate feed rate. Here it's showing 100, so let's go ahead and put in 100. 25 is set at 1000. That's a pretty good speed for locating and searching for the homing position. For a lead screw driven machine, your max is pretty much like 2500. So if you want to increase it, you can always go back and do so. But we're going to follow the settings for 1000. Alright, going on down to 26, that's 250. That's correct. 27 is 3. 30 is going to be set at 1000. That's correct. 31 is 0. Correct. 32, we don't have a laser, so that's definitely disabled. Going on down here to 100, we're going to set that to lead screw, which is 199.100. And the same for, this is all lead screw driven machines, so all these values are going to be 199.100. Alright, perfect. And what's also cool about this is we have a calculator here, so you can calculate based on what type of drive system you're using. So here you see we have options for belt driven, lead screw driven, and here we have 1/8 steps. You can adjust your belt type, pulley type, and it gives you your calculated value, which is really convenient, guys. Alright, so we're going to go on down to 120 here, which is set at 150. 122, or I'm sorry, 121 is 150. So all three of these values are going to match at 150. Going on down to 130. And this is going to be for our travel. So these are based on the machine size. So make sure you copy these values, guys. They are correct. So 333 for the x-axis travel. Now we have the y-axis travel here at 325. and our z-axis travel at 85. Alright, from there we're going to go up to Save to Firmware, and here it's going to show the configuration is updated. Reset Gerbil, you're going to select yes, and it's going to save all these values to the firmware. Alright, perfect, and it's rather quick. So now we can go to the Control tab here, and we're going to jog the machine around, make sure that all of our settings are correct. So let's go ahead and power on our power supply. Alright, so you should hear your fan activated. It's cooling the board. You should hear your drivers activate as well on the board. Alright guys, so jogging the machine around, I did notice that we're going to have to make some changes here in Gerbil settings. So the step direction invert is perfect. Set at 4. That works great. The homing direction invert we need to set at 3. So go ahead and select 3 and then come up here and save to firmware. Alright, once you have that complete, let's come back here to the control. And let's go ahead and jog the machine around, make sure everything is working correctly. I have my increment set at 1 millimeter. So go ahead and set that. And now we're going to go ahead and test our axis. So at the z-axis here, I'm going to go ahead and jog down, so the machine should jog the z-axis down into the material. So as you can see, it's moving perfect. Awesome. Alright, so if I go positive, it's going to go up. Great. Alright, so now we're going to go ahead and test the X. It should move right out into the field. That's a positive movement. And back to the homing position will be a negative movement. Perfect. Alright, same for the Y. So jogging out into the field is going to move the machine back towards our controller. And then moving back, it's going to be back to our homing position. Perfect. Everything looks great. So now we're going to go ahead and home all. Now, if there's any issues, make sure you hit stop job here. It'll be immediate. So it'll stop your machine before it grinds on one of the endpoints if it is in the wrong direction. But since we did change our value to 3, we should have no issues. So we're going to go ahead and home all. It's going to start with the Z. We found the homing position. Now X and Y. Perfect. So now we have homing values. So I'm going to bump it back just so you can see the full homing cycle. So I've got my increment set up to 10. Move it back. This machine's running great. It's awesome. Alright, so let's go ahead and we'll move X over to. And set it to 1. Let's go ahead and move the Z-axis down slightly. Alright, now let's go ahead and home all. That's looking good, looking good. Alright, the X is found, and now the Y. Perfect. That's looking great, guys. Alright, so now we have our machine set up. So all of our settings are configured. Everything looks great. So now we're going to go ahead and run a hello world, guys. So what I want to do now is we're going to go back to our browser. And we're going to open up the CAM software in OpenBuilds. Go back to OpenBuilds. Alright, now here in the software tab, we're going to open the OpenBuilds CAM G-code generator. So selecting that, it's going to open up the CAM program. And here I'm going to show you some of the settings that you can configure specifically for your machine. Start with the new workspace. So if you open this program up before, it'll actually save the progress. So you can open that previous workspace. But we're going to go into a new machine here and go into settings. And from there, we're going to configure our machine. So we are using the Spark Concepts Xpro. This machine is the Sphinx 55. So we're going to go ahead and locate that. The OpenBuilds Sphinx 55. So we'll select that, and it's going to upload all the parameters for the machine. It's really convenient, guys. So we're going to go ahead and save that. Alright, and then the workspace is going to be configured to that machine. So what we're going to do now is go back to our workspace, and we're going to open the hello world. So this is a presetting for your convenience. Once you get this machine up and running, you're going to want to test it out, make sure it can run code properly. So this is an easy way to do that. So we're going to open up the drawing here. We're going to open the Hello World example. And here it's going to populate into our machine parameters. So from there, we are going to generate the G-code, which it's doing right now. As you can see, it's calculating toolpaths. Perfect. And then generate G-code. And from there, you're going to see all the toolpaths. And then we're going to go ahead and transfer this G-code to the machine driver. And here it's going to show the 3D view, which is super cool. This is an awesome feature, guys. So if you have a mouse on your laptop, you can simply select this, move it around, check the machine out while it's which section you're located at. It's really convenient, guys. This is awesome stuff here. And you can do this while the machine is working too, so it's super cool. You can also simulate it. So if you go to simulation here, it's going to show the toolpath of the machine. You can up the speed of the simulation. Let's go to 10. Check that out. That's awesome. Super cool. Very powerful software. Definitely super excited about having this release. It's definitely convenient to a lot of guys. It's user friendly. It's just really cool stuff. So we're going to go ahead and stop the simulation here, and we're going to go ahead and test this on our machine. But first, I want to go ahead and we're going to go and set our 0 point for our machine. So our homing position is a little bit different than our 0 point. Our 0 point is going to be for material cuts. So the homing position is basically just to convenience you, get the machine into a starting position, but it's not the actual starting position that we're going to use. So we're going to go ahead and adjust our machine here. So I have increments set at 1. So I'm going to go ahead and move my X over slightly. And this is just to make sure that your machine does not ram into the sides. So I moved that over. Now I'm going to move my Z-axis down to make sure that it doesn't grind on the top. Let's move that down just like so. And then we're going to move our Y-axis back slightly. And now we're going to set 0 on all these points. So that looks good. So let's go ahead and set that to 0. All right. And now we are ready to run the job, guys. So we're going to go ahead and select this. But once we do, and you have any issues, make sure you hit stop job. It's immediate, guys. All right, so let's go ahead and run this job. As you can see here, I'm following the 3D view here, which is super awesome. It's showing exactly where we are, guys. You also have the G-code editor here, so you can follow the code. But I prefer the 3D view. And like I said, you can also adjust the view of our workspace here. And this is super awesome, guys. Really cool stuff. You can see as it raises up and the tool pathing and then goes back down. This is awesome. Alright, so now we're going to go ahead and stop the job here. I just want to show you guys a couple other things about the software. So here we're going to home all, get our machine back into an open position. I really love those micro limit switches. It makes things so much easier and convenient. Really cool stuff, guys. Alright, so on other things that this awesome machine driver offers, we have a jog widget. We also have tooling options. So you can plug those into the output of our Xpro, turn on a tool for the motor section as well as coolant. Really cool stuff here, guys. Alright, so we have our machine configured. You guys are all set. So your machine is running properly, all your parameters are set, your values are good. So now you're ready to go out and build some cool projects, guys. Thanks for tuning in, and good luck with all your future builds.